Hello, welcome to the part preparation and cable routing within a Cubesat presentation. My name is Jordan Wong, and I am a second-year biosystems engineer.
My name is Freshta Malikzada, and I'm a third-year aerospace and mechanical engineer.
My name is Icd Document, and I'm a first-year aerospace engineer.
And my name is Napsia Buddhamatya, and I'm a third-year aerospace and mechanical engineer. To start off, I would like to introduce you to Mission Real Op at UC Davis. Mission Real Op is the first undergraduate-based CubeSat team. A CubeSat is a miniature satellite that can be used to analyze the Earth and outer space while orbiting in low Earth orbit. We four are a part of a smaller team called Structures and are responsible for the overall framework of the CubeSat. More specifically, Jordan and Richard are representing a structure subteam of parts preparations, and Freshta and I are representing the structure subteam of cable harnessing. Parts preparation handles the documentation of the CubeSat, and cable harnessing is responsible for the cable management of the CubeSat. I'll pass it over to Jordan to explain more about parts preparation responsibilities.
Thank you, Napsia, much appreciated. So the parts preparation team, as Napsia mentioned, is responsible for the documentation of the CubeSat. So in any sort of engineering project, documentation is a very important practice. It can be used to sort of check your progress, keep a record of one's progress throughout a project through a period of time. It can be used as a resource bank for whatever information one might desire about a certain component or part. And probably most importantly, it can be used to check for errors down the line to see where the source of the error stems from. So parts preparation, we put a lot of focus into three types of documentation. The first type of documentation are the parts drawings. These drawings are of every single component in the CubeSat and are CAD'd out using SolidWorks. The purpose of this is to send them to manufacturers for manufacturing. So as you can kind of see in figure 1 and 2, those are kind of what the drawings will look like. In particular, the specific part in those figures 1 and 2 is the Z-face, which acts as sort of the top and bottom of the CubeSat, as you can kind of see in figure 4. So these parts drawings need to be very particular. They need to have the information that a manufacturer would need in order to, well, manufacture our part correctly. So for example, things like dimensions, angles, arc lengths, and tolerances as well, among other things. So once the manufacturer makes the part using the part drawing and sends it back, we have documents called mechanical part inspection documents, or MPINs for short. These documents essentially act as sort of a quality check to make sure the manufacturer made the part correctly. And finally, we have the interface and control documents, which detail how each part interfaces with other components, or in other words, how does this part fit together with other parts? Which is very important when actually putting together the entire CubeSat. So now I'll leave it to Richard to explain the MPINs and ICDs more in depth.
Thank you for all that information, Jordan. So as he was saying, MPINs and ICDs are one of the two most important documents that parts preparation as a subteam handles. And what the MPIN entails is it's actually shown in figure 1. That's an example of what an MPIN document would look like. And these documents pretty much double check all the dimensions of the parts to see if everything was measured properly. And these documents may also contain errors that could cause potential problems in the future. Next is the ICD document, which we weren't able to include a photo of, but these documents contain information as the part is where it's relevant at in the CubeSat. And it's done by having this complex coordinate system that matches with the actual CubeSat, so the user has greater understandability when they're looking at this part. These documents also include numerous of other things, such as its relevance to the mission, its mechanical interfaces, and its electrical requirements. And these documents need to be handled with extreme precision when writing, so when the person is reading it, they can fully understand how this part is incorporated into the CubeSat. And I'll pass it over to Napsia to talk about the cable harnessing.
Thank you, Richard. Cable harnessing is a team that is tasked with acquiring the wire lengths that are necessary to connect the different sections of the CubeSat together. So these sections may be batteries to coils, power to deployment switches, or the flight computer to the science board. These wires are used to power and connect these different sections together for communication purposes. After the wire lengths are obtained, the Mission Real Up electrical team can begin building the internal circuits inside the CubeSat. The wire lengths are very important in building the final product because it ensures that the internals of the CubeSat are compact and there are no unnecessary slack in the machine. I'll pass it over to Freshta to explain the exact ways the different sections are connected and how these wires are created.
Thank you, Napsia. So we used SolidWorks to route the wires by first modeling the connectors with numbers of pins that were needed on the shelves. So there's connectors with different numbers of pins on each shelf, like there's 40-pin connectors or there's 2-pin connectors and so on. And then we had SolidWorks recognize those as connectors, and then we put the connectors inside the CubeSat and their specified shelves and made the needed routes between each connector. And then we adjusted the wires so there's no overlap between the wires inside the CubeSat. And then we obtained the wire lengths by flattening out the wires and getting their drawings. In figure 3, it shows a block diagram of how we've done the routing. And each block diagram represents the shelf that the connectors are attached to, and the numbers represent the number of pins on the connectors, and the lines represent how the connectors are connected to each other. So if we look at the left side of the block diagram on figure 3, deployment switch has a 2-pin connector that's connected to the power board that has a 14-pin connector, and then 2 pins from the power board is connected to the HDD, and then 3 pins to the XYZ solar panels, and so on. I'll pass it to Richard to talk about the conclusion.
Thanks for that, Freshta. And so overall, it is like shown how parts preparation and cable harnessing together have helped in the development process of this CubeSat. Parts preparation was crucial because of its documentation with documents such as the MPIN and ICDs, so parts are better accounted for and errors could be found more quickly, and cable harnessing for finding the wire links and where these wires will be connecting.
Yes, and to sort of add on to what Richard was saying, both these teams are pretty important because together they provide a sort of basic schematic for how the CubeSat is assembled. So those assembling it will have a pretty good idea of how things will fit together and how the wires will incorporate into the whole picture. But more importantly, and looking to the future, both these teams are very important because the skills and abilities that the members develop and acquire through working through these teams can be used in future CubeSat missions, which in that case, those missions will ideally be more streamlined because members will have experience with the documentation practices and the necessary procedures that one must take in SolidWorks, and etc. So with that, we'd like to acknowledge the structures leads of Milena and Chris for their continued guidance and support throughout this entire endeavor. And we would also like to thank our faculty advisor, Stephen Robinson, for his continued support of Mission Real Up. We thank you for listening to our presentation, and we hope you have a wonderful rest of your conference. So with that, have a great day, and thank you so much. Bye-bye.